Okay, so today we're going to be doing 4.1 notes, which are transformations and rigid motions. This is kind of an overview of all of Unit 4, like what we will be getting into. So our goal for today is to define rigid motions. Also known as isometries. Those words are used interchangeably. And to perform transformations. So we are going to talk a little bit about a couple of terms before we get into actually performing these transformations. A pre-image is going to be the input or the original image. And then your image is going to be your output or your new image. Both of these take place with a transformation. Okay. So I keep saying this word transformation. You guys already know what a transformation is. A transformation is something that goes through a change. So this is a function that changes, and it could go through any kind of change. It could change position. It could change shape. And or, because it could do one of these things, or it could do a multiple of these things, and or size. So this would be an example of a transformation just written in function notation. This would be the transformation. So that's going to be the function. So A is going to be your input, and A prime is going to be your output. So when the point A will move, we'll denote the new image as A prime. So you'll see that as we go through. Go ahead and hit pause on the video and in just a minute after I give you directions. It says, based on the examples, come up with a descriptive definition. So I want you guys to try and look at the example and not examples to come up with what is an isometry or a rigid transformation. A rigid motion or a rigid transformation, we'll add that word in there too because these are all used interchangeably. So you have to be able to recognize it as any of those words. But all of these, the translation, you're given a pre-image and an image and something is happening. These would be not examples, but I want you guys to try to, on your own, come up with the definition. So hit pause now and try to come up with those. Okay, so you should have taken a couple of minutes now to go through these definitions. So you'll notice that a pre-image can change directions. Okay, it can flip an image. It can slide an image. Here it was on the left, now it's on the right. It can flip over a line or reflect across something, or it can rotate an image. But what it can't do is it can't get smaller. Here it also is getting smaller. Here it's getting larger. Here it went from being like normal looking P to a super skinny tall looking P. So it can't distort the image. It can't change the size of an image. So what did you guys come up with for a definition? Your definition should look something like this. It's a change in position, but it does not change shape or size. So it cannot change the shape or size. It is just changing the position of the image. Translation, that's the next one. So what do you notice about the examples versus not examples? What did you guys come up with? Okay, so you should have had something along the lines of it slides all points along a vector. You probably did not come up with the word vector, but I am now telling you that. We're also going to take a minute to define it in a second. So it slides all points along a vector. And all of these pre-image and image, they stay the same shape and size. So what we could call that would be an isometry, because that's how we defined an isometry. It does not change in shape and size, so an isometry. Or again, that could be used, you could use rigid motion or rigid transformation for that as well. But we are going to take a minute and then we are going to side note on what is a vector. And I do have another video. The link is also in the material, so if you want to hit pause now and go watch that video, it's a small clip from Despicable Me that actually defines a vector. Okay, so hopefully now you went and watched that video, and you should be able to define a vector as a mathematical term that quantifies both magnitude and direction. So it's measuring magnitude, which just means the length, and direction. The way that a vector is written, it's written in almost like a coordinate point, but instead of parentheses, they are like pointed brackets, and you'll have A comma B. The A does tell you how far left or right you'll move, and the B value will tell you, yes, A is going to tell you how far left or right, B will tell you how far up or down you're going to move. So let's say you had the vector 3, -4. The same way you would tell me how to get to that coordinate point is how you would describe it. This would go right 3, down 4. So if it was moving along that vector, you would take every single point on the image and you move it right 3, down 4, and that would be where the new image would be. Okay? So you can figure out how far it moves because you guys know the distance formula. So if you move right 3, down 4, the distance formula could tell you the magnitude, the length that is moved, okay? The direction of that it moves. So let's go ahead and flip this over. And if you're looking at a reflection, what did you guys get for your definitions here? Okay, so your definition should include something about flipping all the points over a line. The line that it's flipping over, we'll actually call that the line of reflection, so you might want to make a note of that. We'll talk about this more later on in this unit. Or you might just describe this as a mirror image. Okay, it's a mirror image. You also will notice that it cannot change size. So here this almost appears to be a reflection, but you'll see the image gets smaller compared to the pre-image. So it cannot change shape or size. Because it's not changing shape or size, we will classify this as a type of isometry. You'll notice that we're kind of, like I said, we're going to do an overview today of Unit 4, and then we're going to focus on each of these types of isometries in more detail in each lesson. So, moving on to a rotation. What do you notice about the rotations, what they are and what they are not? What did you guys put for your definition? So some of the things that you want to make sure you have in your definition is that you want to make sure that you describe it as an image is going to turn all the points around a fixed point. That fixed point is called the center of rotation. Again, we'll get more into that when we talk specifically about rotations, but just recognize a rotation as it's turning all the points around a fixed point, and that fixed point is called the center of rotation. The angle of rotation is going to tell you how far the image is going to turn. Okay? You'll also notice that these remain to be the same shape and same size, which means this is also a type of an isometry. I have 3 examples of how I'm going to show you how to perform a transformation. Okay? Some of these may be an isometry, some of them may not be. You don't have to worry about classifying them. You just have to worry about actually finding them. So the easiest way to do this is to start by identifying, here we have this triangle. Identify the points of your pre-image. This is going to be our pre-image, and we're going to find the image. So we'll call this A, B, and then C. So if we do this, the first thing you want to do is you want to identify where is A at, where is B at, and where is C at. And if you do that portion of it, then what you can do is you'll be able to find where A prime moves, B prime moves, and C prime moves. So A is at the origin, so that's at 0, 0. B goes right to and not up or down at all, so 2, 0. And C goes not left or right at all, so 0, but it goes up 3, so 0, 3. Now, our rule says that our original x becomes x minus 4. So what I like to do is I like to stick with one rule at a time, and I take care of all of my x's first. It does not matter how you do this. So I go, okay, this x was 0, here is x minus 4. So 0 minus 4 is negative 4. This x was 2. 2 minus 4 is negative 2. This x was 0. 0 minus 4 is negative 4, because that's what the rule tells you to do. Now I found all the x's. Now what I'm going to do next is find the y values. So this y value says I'm going to take the y value and I'm going to add 3 to it, because this was the original, was just y, and now I'm going to add 3 to it. So my original y was 0. Add 3, I'm at 3. My original y was 0. Add 3, I'm at 3. The original y was 3, so 3 plus 3 is 6. So now that I have these 3 points, A prime, B prime, C prime, I can go ahead and plot those points. A prime is at negative 4, 3, so left 4, up 3. That's going to be A prime, and I'm going to label it A prime. So I can see A moved to the 1, 2, 3, 4 to the left, up 3. So it moved left 4, up 3. This is called coordinate notation. That's how all 3 of these are written, are in coordinate notation. So you'll notice we'll call that coordinate notation later on. You don't have to worry about that name right now, but that's just kind of a pre-introduction of it. All right, so B is at negative 2, 3. So negative 2, 3. So left 2, up 3. That's going to be where your B prime is. So I'm going to label that one. Now C prime is at negative 4, up 6. So right here. And I'm going to label that C prime. And then what you can do is you can connect the points the same way they were connected before. A is connected to B, which is connected to C, which is connected to A. And I have this triangle that just shifted. So what did this undergo if it just slid from this pre-image to this image? That was a translation. Okay. So our A, our B, and our C are the exact same in these other ones. So I'm going to go through and I'm just going to label those.